Hello everyone, I'm Yubao Liu from Toyohashi University of Technology. Today I would like to share this paper, KMOP-vSLAM, Dynamic vSLAM for RGB-D camera using KMOP and OpenPose. Although tremendous progress has been made in simultaneous localization and mapping, the same rigidity assumption limits wide uses of vSLAMs in the real environments. In computer vision, smart robotics, and augmented reality, to make SLAM more robust in dynamic environments, all lies on the dynamic objects, including unknown objects, need to be removed from the tracking. We proposed a novel dynamic vSLAM using KMOP and OpenPose for dynamic indoor environments. We proposed a novel moving object detection method that is based on the probability model using KMOP, human detection, and geometric methods. We proposed an efficient geometric outliers detection method that uses moving object emission of previous frame and a good matched feature selection algorithm. KMOP is used to segment the objects, including the unknown objects. We integrate all above algorithm technologies to detect and remove dynamic objects, including people, in dynamic indoor environments in real time. This is the whole architecture of the proposed system. 3 models are run in parallel. Every RGB image will pass through the feature detection model to extract the ORB features, and at the same time, it will also pass through the human detection model to detect human. And the depth image will pass through the KMOP segmentation model to get the pixel-wise segmentation results. After do the moving detection, we can get the mask of dynamic objects, and this mask of dynamic objects will also be used for the next iteration to improve the accuracy of geometric tag. The results of geometric tag and human detection and segmentation are used in the moving detection model to detect the dynamic objects. And finally, the camera eagle motion is estimated using the good matched features after removing the outliers on the dynamic objects. Now I will introduce the semantic model. KMOP is used to segment depth image. This is the result of KMOP. Before we introduce the moving detection model, we firstly introduce the geometric constraint model and the human detection model. Now I will introduce the geometric constraint model. Firstly, we use the previous image and the mask of previous image to generate the rendered previous image. By removing the dynamic features using the mask of previous image, then we match the current image and render the previous image. This is the current image, this is the rendered previous image. We match them and using the selected match, good matched features to calculate the fundamental matrix. This fundamental matrix is used to calculate the epipolar lines. And the epipolar lines is used to calculate the geometric error of all the matched features between the original previous image and original current image. Then we judge inlier and outlier features by comparing the geometric error with the threshold. If the error is larger than the threshold, then this feature is classified as the outlier. Finally, we calculate the moving probability using the geometry check, which I will be introduced later. We use the fundamental reproduction error as the error function. F is the fundamental matrix, L is the epipolar lines. The red points in this figure is outliers. These outliers is decided by comparing the geometric error with the threshold. Then the key is how to decide the threshold. We calculate the average value, minimum value, median value, maximum value of all the geometrical errors. The geometric errors of all the frames. We found most geometric error is lower than 5. These values belong to the dynamic features. So we can set the threshold to 5 in environment. We define the geometric moving probability. This probability will be used to judge dynamic objects. PGI is the moving probability of each object based on the geometric check. Out I is the number of outliers in each object using the geometry check. And in I is the number of inline of features in the object using the geometry check. Similar to the geometric moving probability, we also define the OpenPose moving probability. PHI is the moving probability of each person based on the human detection, and HI is the number of OpenPose features detected on each person, and H is the total OpenPose features on each person. The next is to judge the dynamic object. If person exists in the current image, we use both OpenPose probability and geometric Moyne probability. Omega is a weight parameter indicating how much the result of human detection is trusted. If no person exists in the image, we only use the geometric Moyne probability. If the Moyne probability of each object is larger than a threshold, then this object is judged as a dynamic object. Then, how to decide the threshold? For example, we cluster each image into 10 clusters or 10 objects. We calculate the Moyne probability, the geometric probability, the human OpenPose probability of each object. We, for example, in this case, we found the object C0. The Moyne probability of these three values is very high, so this object is judged as a dynamic object. We can set a threshold according to by referring the probability value of each object. From now on, I will introduce the experimental results. We segment depth image using k-means, and also we detect the human person, and we calculate the geometric error by calculating the epipolar length and judge outliers using the geometric check, and use the results of human detection, k-means segmentation, and geometric check to generate the mask of dynamic objects. These masks are used to remove dynamic features on the dynamic objects. We compared our algorithm with a similar proposal, new RGB-D SLAM and the ORB-SLAM 2. We compared absolute tracking error and relative pulse error. We compared them using the error matrix of root mean square error, mean error, minimum error, and maximum error. Our errors is smaller than others. We achieved better tracking accuracy than others. Our algorithm can run about 4 Hz. In conclusion, in order to remove the drift error in tracking caused by dynamic objects, including unknown objects, a novel approach is presented that combines geometric check, k-means, and OpenPose to detect Moyne objects and remove outliers using the mask of dynamic objects. An efficient geometric outlier detection algorithm is also presented that using the mask of dynamic objects of previous frames, a novel probability model that using geometric Moyne check and human detection is also proposed to judge the dynamic objects. That's all for my presentation. Thanks.